Welcome to MOOC course on Introduction to Proteogenomics. In the previous lecture, Dr. Bing Zhang provided you the capabilities of an online tool linked Omics. In today's lecture, you will be exposed to the various steps involved in analyzing large data set using linked Omics. So, let us welcome Dr. Bing Zhang for his last lecture.
So, let us go to the new analysis, and then there are a few steps you need to follow in order to perform this analysis. Let's start with proteomics data. So, basically we want to ask which proteins in ovarian cancer are associated with poor prognosis, and which protein is associated with poor prognosis in ovarian cancer. In order to do this, first you have to identify the ovarian cancer data set to do the analysis, or ovarian cohort. So you can browse, but let's do a search ovarian. And then you can identify this TCGA_OV. That is the cohort we want to look at. Basically, it's a TCGA ovarian cohort. And then you click on that. And then it will give you the next step, select a search data set. So as I mentioned, the goal of the linked omics is allow you to go from any attribute. For example, you can go from the mRNA or microRNA or mutation or proteomics to any other attribute. But here we have a fixed question. We are interested in survival, right? Survival is a type of clinical data. So within the step 2, we want to define the search data set and the search attribute. So here we want to start with clinical data. Let's say you filter for clinical data, and there is only one type. Let's say you select the clinical data. And now you have step 2B as an option. But let's say if you are only interested in, for example, a certain stage of ovarian cancer, or maybe you are only interested in a certain subtype of the cancer, and then you can do the analysis for the subset of tumors. But today, let's just say we do the analysis for the whole cohort. And then we select the search within the clinical data, right? There are multiple types of clinical information like the platinum resistance status or overall survival. So today we are going to select the overall survival. Now basically you defined what to use as a query attribute. Basically it's within the TCGA ovarian cohort. I'm interested in the overall survival. And then I want to ask which proteins are associated with overall survival, right? So then on the step 4, the data type, let's select the proteome. So for this cohort, both Johns Hopkins University and PNNL, they both did proteomics data generation for kind of overlapping subset of the cohort. But today, let's just say we choose a PNL data. You click on the select next to the PNL data. But here, after we finish this proteomics analysis, you can come back and then you can select, for example, RNA-seq, and then you can correlate the overall survival to RNA-seq. Or you can select the copy number and then you can correlate survival to copy number. But now we are going to do the proteomics only. And on the step 5, let's select Cox regression. So this is for survival analysis. And then submit query. Any query that has been queried by other people, because some other people already done this analysis and the result is saved. So that's why it's so quick. And now you get this, and then you click on the view. And you can also search the gene you are interested in. For example, KRAS or some other genes. Let's say ovarian cancer what gene could be interesting. Anyone has any suggestion on which gene you want to search for? Yeah, maybe let's look at the KRAS. Yeah, it looks like it's not significant. The p-value is 0.6. TP53. TP53. It's not significant either, but it's apparently there is a little bit of trend like higher expression is associated with poor survival. Yeah, and you can also go to the bottom of this page, and this will show you the top 50 genes. I don't know, 50 or 25 genes that are most positively correlated with survival or most negatively correlated with survival. So we found this to be useful for get a quick view of the top genes and the detailed data. It's binary data. It's subtype 1 versus other subtype, and then you just have black like this 2 parts, right? But for survival data, it's only you have death event and still alive or dead, right? But then you also have the time of survival. So basically, the first bar, this bar at the bottom shows you these are probably the people who have died, and these are still alive. And then within each group, and then this is the survival time. So most of these are censored data, right? Most of them haven't died, so it's censored. But these are the ones with actually death events. So basically 2 groups of people, and then within each group you have survival time from short to none. So I think, and then if you want to do some pathway analysis for this, you can click on the inter-interpreter, and then you can do ORA or GSEA similar to what we have done before. But if you submit the query, and basically it will give you the WebGet stored report. And we have done that before, so let's say we don't need to do that now. Rather, I think we can go back to perform a new analysis. And in this time, you still do the same analysis, but you ask a slightly different question. You ask which copy number change is associated with survival in this ovarian cohort. And after that, you do another query, which in the RNA-seq data, which mRNA abundance is correlated with survival. And after you get results from all the 3 platforms, and I can show you how to do the link compare. So you can go back to new analysis and repeat what we have done, but just change the target set, target data set. The copy number is SCNA, and if you filter the data type for SCNA, and then you get multiple 4 rows, right? Because the results can be, we have results at the both focal level and the gene level. And then at the gene level, the data can be thresholded or without threshold. In this case, we pick the one without threshold. Pick the third one. What is it? Yeah, we pick the SNNA gene level file host GSTIC 2. That is the algorithm used to do the analysis. Oh, sorry. At the very top, you still select clinical. I'm sorry. Yeah, we should select clinical, and it's in the target data set that is somatic copy number. Yeah, it's step 4. Step 4, select copy number. And then you can also view the results for copy number the same way. Okay, let's say if you have were able to get 2 or 3 results from this. For example, if you get all the 3 RNA-seq, copy number, and the proteome in this OV dataset associated with survival, now you can do the link compare. And what you do is you select on the third column, this select column, you select, let's say, all the 3 of them, and then you click on compare. Now you have this table with all the results. So basically, in the first few columns, you have the 3 results from the 3 platforms. Let's see, this is ID 24, correspond to this ID 24. So this is the results from RNA-seq, and then you have ID 56. This corresponds to the results from copy number, and the ID 57, this is the results from proteomics. Basically, each of these you have the signal strength, meaning the hazard ratio, and then you have the p-value FDR, right? And then here, we use a SUMZ, which is a meta-analysis method, try to summarize the p-value from the 3 analyses. And then you get the sum statistic, and then sum the p-value, and some FDR. So let's sort the results based on the p-value. And as you can see now, before for individual platform, we get very few significant genes, right? In proteomics, we didn't get any gene that passed the FDR cutoff. But now we can see after you integrate 3 platforms, there are a lot more significant genes than individual platform. This indicates, although each platform don't give you the signal strong enough to pass a cutoff, but maybe all of them point to the same direction, that give you more confidence. So when you put the result together, and you get the enrichment. And then you can look at the top genes to see their minus log meta FDR, meaning this is integrated FDR, and these are the top genes, positive genes and the negative genes. And then you can also have the result in the heat map. You can also redo the filtering, and for example, you run the filter rather than setting the FDR as 0.05. Let's say if you renege this to 0.1, submit filter, this will give you more genes to look at. So basically, you can adjust this to get the genes that pass your cutoff. For example, now if we renege the FDR, and then we get more genes to look at. And all these results also can be downloaded and saved by click on the download figures. So again, and you can go to the link interpreter and, for example, select GSEA, and then now you can submit this, sum this statistic as a rank metric to rank the genes, and then the analysis will be performed, the enrichment analysis will be performed against this summarized statistic rather than individual ones. Again, the result will be the same, very similar to what we saw before for the GSEA in WebGestalt.
In today's session, you got a demonstration about how the 3 modules of linked omics work using ovarian cancer TCGA dataset as an example. It is also shown how the tool can be used to generate survival information from a target gene. Using data from RNA-seq, copy number variation and proteome level information on the effect of target gene on survival was demonstrated. Finally, using the third module of the tool, it was demonstrated how the results appear and it can be interpreted. In conclusion, we hope that now you have a fair bit of idea how you can use these available tools and use them for your own research. Thank you.